Hi everyone, welcome back to the online tutor. So today I am going to discuss a very special part in our applied paper, relative acceleration, right? So relative acceleration, I'm going to discuss 2019 ALL paper problem, right? So you can see the diagram in board now. So the triangle ABC and LMN in the figure are vertically cross sections to the center of gravity of two identical smooth uniform wedges, capital X and capital Y respectively, with ACB equal LMN equal 60. So here this is 60 degree, this also 60 degree, incline is same, and also ABC and others are here, this is 90 degree, such that the face contained BC and MN are placed on a smooth horizontal floor. The wedge X is of mass 3m, so I put 3 mg here, is free to move on a floor, and wedge capital Y is kept fixed. The line AC and LN are in the line of radius flow, right? So that those data are normally provided. Slope of relative to the face. Two ends of the light inextensible string passing over the two small pulleys is fixed at A and L are attached to the particle P and Q of mass M and 2m respectively. At the initial position, the particle P and Q are held on AC and LN respectively. Here this is A, this is L. So the particles are P and Q. P and Q. The masses are M and 2m, right? And at the initial position, the particle P and Q held on AC and LN respectively, such that AP equal AL equal LQ. AP, LQ and AL are equal, which is A, right? At the starting position, right? So when the T equals 0, right? By the way, it's moving now. When the system released from rest, the particles are going somewhere and the wedges are moving. So this is fixed, right? This wedge is moving to I don't know, we'll see, right? The system released from rest. Obtain the equation sufficient to determine the time taken by capital X to reach capital Y in terms of A and G. Okay, so in this question they asked to determine the equation, so the largest simplification is not required, right? So the thing is, you should apply the Newton's law and the fundamental theory, so F equal ma and all, and the relative accelerations, the principle of relative acceleration is required. So these things are checking in that paper. Okay, first of all, what you have to do, you should draw the diagram and insert the all data. So determine the put the forces, right? And here the my tensions, right? You can see in red color, and the reactions R and S over here. Then the masses and all, right? then after, what you have to do, you should assume somewhere this wedge, this fixed, this capital X wedge is going. So normally this is 2 mg, no? This is particle Q. It's going down, and this is going up, right? And this wedge is not fixed, right? It can be moved. So I assume this wedge is moving to the right hand side. So that means capital acceleration of capital X relative to the earth is capital X, right? And also the Q which is on the fixed wedge Q relative to the earth, so that means because it's fixed, E, right? It's going simple F with simple F acceleration 60 degree. And also the P, the particle P is on the non-fixed wedge, right? It's in the moving wedge, so that means their acceleration, the P acceleration relative to the capital X, right? Relative to the capital F. I don't know the acceleration because it's depend on the wedge acceleration, so I assume simple F. But surely it's relative to the wedge, no, it's going up with 60 degree. Simple F1, so this is simple F1, right? Okay, so there the problem is we have capital F, simple F, F1, all three variables, right? Y is fixed anyway. And what to do now? So I think before writing the F equal ma for the whole system and the particles, we can do something with the distance. We can write the equations for the whole length of the string. So I assume the string length is simple L, right? Simple L, and I this is fixed now anyway. I assume this as X, right? And this is from here, this is Y, and here it's Z, right? So actually this distance is relative to that moving wedge, right? It doesn't matter. So X, Y, Z. Now the addition, right, plus these constants, right? L dash, right? And you can differentiate it by time. 0 X dot plus Y dot plus Z dot, X double dot, Y double dot, Z double dot. Okay. So now we have this acceleration. Actually, you have to understand this Z double dot, right? Z double dot Z mean the acceleration of this P particle relative to that wedge, right? So it's similar with the F1. So Z double dot similar with the F1. So then Z F1 can be written with minus. So but remember this is Z double dot is measured from here to down. So that my F1 is up, right? So that means surely this is minus F1. So minus Z1, right? So therefore minus and Y double dot, Z double dot equal minus Y double dot minus X double dot plus X double dot plus Y double dot. Okay, and also this Y, right? So this Y is going down. And yeah, the capital F also equal to minus simple X double dot, because simple X double dot is measured from here to here, right there, and here capital F is going right hand side. So that means minus X double dot. So then Y double dot is same, Y double dot equals simple F. So that means simple F1 can be written with simple F minus capital F. Simple F minus capital F. Now we have the connection between these accelerations. Okay, now the all accelerations are ready, and now you can write the equation of the Newton law. You can apply Newton law F equal ma for the system, for the motion to X. Yeah, applying F equal ma. So first of all, I am going to apply for this whole system of capital X wedge. So you can see, so there's that direction. Here T is there and F is already here. Okay, and the wedge mass is 3m with acceleration of the wedge, it's capital F, plus this particle simple m into acceleration. You know, here the P acceleration is in terms of relative to the wedge, right? So we need acceleration of P relative to the earth, apx plus axc. Px mean F1 this way, x mean capital F. Anyway, simple F1 mean F minus capital F up plus capital F with 60 degree, right? So then here plus m to that direction, capital F is already horizontally, capital F plus simple F minus capital F cos 60. Right, so now that equation is ready. Equation number 1. So the next thing, we can put F equal MA for the P up, only for P, right? Then it's T minus mg, this is 30, no? Cos 30, mg cos 30 equal m times this way, acceleration, yeah, it's same, no? Simple F minus capital F plus capital F cos 60, capital F cos 60. This is my second equation. Okay, so then next last one, F equal ma for this q particle. So q, F equal ma for the down. This is 2 mg cos 30, 2 mg cos 30 minus t equal 2m. Accelerations q is simple f, just only simple f. Fourth equation, 1 2, and here you have to put another number, 1 dash, 1 2 and 3. Okay, these are the equations that they expected, right? So I will okay, so anyway, what we have to do, you have to find the sufficient determined the time taken by x to reach capital Y in terms of A and G, no? Okay, so then one more equation should be applied. You know, this part, this wedge system is going right hand side, then we have to apply some linear equation, right? Some linear equation. So then I think S equal ut plus half at squared is suitable, because the starting velocity is 0. S equal ut plus half at squared for the system of wedge, for the wedge. So the distance is a and ut all 0, half. Acceleration, you know, acceleration is the wedge acceleration, it's capital F, and time taken is t square. So you need capital F, right? So actually capital F can be found with association with these three equations, right? So this is the 2019 LL paper, that is what they expected. So I will show you how this marks given, right? So normally they given 15 marks for the forces, right? So forces diagram, and the acceleration component they have provided another 20 marks, right? So then 35 for the system forces and the acceleration component. This is 15, and the accelerations, so this thing, right? This all they given another 20 marks. And also for these equations, right? F equal ma equation, each equation, the main equation they given 15 marks, right? And the next others they given 10 for each, right? So the last one another 10, right? So the total mark is 80. Actually easy, right? So you should understand the fundamentals. So these days in exams they are checking your fundamental knowledge, right? So you should have a fundamental knowledge about the accelerations, right, and the Newton laws, and then the all marks can be taken without any doubt. Okay, so that is what I expected to do in this sum, right? So thank you very much for watching, and stay tuned. I will upload more theories and questions. Have a nice day. Bye.